Hello everyone, this is Dr. Marrero. Welcome to the second episode of our new podcast, Calculus Prerequisites. The first episode, that was last week, I talked about number sense. If you have not had the opportunity to watch that video, please do not hesitate and go and join this learning community. This week, we are going to talk about another group of big ideas that we are going to enclose those big ideas into a second important field in mathematics, prerequisite. I'm talking about algebra. So do not skip this video. It's going to be interesting. And by the end of the video, I'm going to also share with you, at the end of the podcast, I'm going to share with you the comments, the very smart, intelligent comments from our audience and from our viewers and subscribers that I appreciate a lot. I'm gonna pick some highlighted comments about these podcasts and in general the videos from math topics. Also, I'm planning to discuss at the end of the podcast one important article that I read this morning from The Economist, that important magazine, about results in mathematics and reading. That will be at the end of the video. So let's start with the second podcast, Algebra. Algebra is a very extensive field in mathematics. I call algebra the grammar of the mathematics, the way we write mathematics. So that is important prerequisite before you start learning calculus. I'm going to go over some important ideas and topics and skills required to be successful in calculus. Remember, this is just a podcast. I'm covering just a few minutes of a big idea that is the preparation for calculus. If you master algebra, I think you have more than 50% chances to understand every topic in calculus. When I said algebra, I'm talking about structures, talking about everything under structures, equations, for example. From linear equations, how to solve linear equations, quadratic equations, talking about exponential equations, talking about logarithmic equations. I'm talking about trigonometrical equations. Radical equations with radical equations. So we must know or we must master the procedures about this particular structures. Probably I'm missing something, but just write your comment below. This is first learning set. If you have not watched the video about learning sets, I invite you to do it. It's an idea from my own experience as a teacher, how to teach math, how do I teach math, how do I learn math, and I use the learning set. This is a learning set. The knowledge of structures, how to write structures, and what is the meaning of the structure, specifically equations. But also, let me use a different color here, we had to work with inequalities. And we have to establish the difference between something like 3x plus 1 equals 8 and something that is 3x plus 1 greater than 8. or less than 8, or greater than or equal 8 in terms of solutions. And in this particular learning set, inequalities, solutions, and linear function solutions, we need to know that. What is the difference? That right here, we are going to have only one x value that satisfies that structure. And here we're going to have infinite numbers of values. And this is when number sense comes to play, when the first podcasts come to play. Do you know this? Do you really understand the differences? That when you're solving quadratic equations, you are going to integrate that to functions. Because there is a clear and significant, essential, critical relation between the structure and its possible graphing representation. Because then we're going to move to one of the big ideas of algebra, which is the definition of functions. So do we know how to translate all of that graphically? Can we move all of that to functions or to a geometrical perspective on the coordinate system? Because this is another important main big idea. Do we know the Cartesian coordinate system? The Cartesian system? Are we are clear about the format of this playground? That every point in the first quadrant, both coordinates are positive, and in the second quadrant, the x is negative and the y is positive, and in the third quadrant, everyone is negative, and in the fourth quadrant, we have here the x positive and the y negative. Do we know that format? Because that format will be important later on in trigonometry, which is another big idea inside the algebra. I don't want to separate trigonometry and algebra. I would do it for this podcast, but I want to start with the best, I think, approach to mathematics, that is establishing connectivity. So structures, graphing representation, and then start moving to functions. From the very definition, from the very paragraph, that set is a relationship between two sets in which every element in one set has only one element associated to that element in the other set. And we know vocabulary, function vocabulary, structures vocabulary, equations, inequalities, quadratics. Because if you go back here to equations and you go back here to quadratics, you have to talk about polynomials. Do you know all the vocabulary about polynomials, monomial definitions, binomials, trinomials, degrees of polynomials? Why is important and why is that connected with structures? Because if you are finding a solution of a quadratic equation, I don't know, let's put it easy, 8 equal x to the power of 2. That's an equation. That's a quadratic equation. The learner must know that you're looking for two solutions. Because you know that x is equal to the square root of 8, but that square root of 8 can be positive, can be negative. And later on, when you translate that into, boom, the coordinate system, the Cartesian coordinate system, you're going to generate a function that is called the parabola. And when you're finding those values, you're finding solutions. And here, the student associates that two solutions are possible. And one solution is possible. And no solution is possible. And then is when it comes the complex numbers. But this is only the first podcast about algebra. So we are going to have more podcasts about algebra. But look, structures is a learning set. And we need to understand that. And trigonometrical equations also will be related with the Cartesian coordinate system as a structure, and solutions, and radical equations here. Yeah, x plus 1 equals 7, for example. That's an equation. We must master this. So understanding the number of solutions depends on your understanding of structures. The coordinate system. Why is it important to understand the coordinate system? Because it's everything. It's the playground in which you are going to learn calculus. Calculus is the analysis of the change. And that change happens in functions. So, the idea of functions start with the vocabulary, start with the notation. Function notation, the f of x, that many do not understand. The ideas of domain, the idea of range, the idea of x and y, the idea of independent variable and dependent variable, in order to move this to the application of calculus. But we cannot apply something that we don't know how to use, something that we do not understand for what purpose it was created. So function is important because when you understand this set, notation, vocabulary, then you can move to the rest of the functions needed. You need the linear functions. You need to know the forms of the linear functions, all of them. The point slope, the slope-intercept form, the standard form. Do you know how to construct linear functions algebraically? So it's not only graphically, it's constructing the structure of the linear function. Do you know the classic questions to construct linear functions? So you must know that. You need 2 points to construct a linear function. Because with the 2 points, you come to another super big idea, the slope of the line. But do you know the slope? The idea of the slope? The graphing representation? The rise over run? But also the delta y over delta x, or the y2 minus y1 equals x2 minus x1, or delta y over delta x. This is the end. This is the final destination. That we need the slope and we need at least 1 point to generate the structure. So we need to master the ability to generate structures. This is linear function. And the same happens with quadratic functions. And the same happens with trigonometrical functions, logarithmic functions. So I'm talking about sine of the angle. I'm talking about cosine of the angle. I'm talking about the exponential function. I'm talking about the log function. I'm talking about the natural log function. I'm talking about many of them that depends on structures and depends on a graphical representation, because then you gotta move to something that is called function transformation. And as a teacher, I can tell you, a function transformation is one of the most difficult topics in algebra. to teach and understand algebra, because the translation along the axis, and this is when X and Y Cartesian system comes to play again. So what is the difference between the pattern function and one of the kids of the pattern function 2 to the x plus 5? Okay, we have a horizontal transformation right here. And what is the difference between the pattern functions and another children 2 to the x plus 5? What is the difference between this and this in terms of graphing representation? Function transformations. Do you know function transformation? Do you know function transformation? And do you know the end behavior? And to understand the end behavior, we have to understand domain, range of the functions. What happened in the infinity? What happened in the negative infinity? What happened to the x? What happened to the image of x, which is the range? I like that word, image of x, through the function f. I like that. So function is a big idea in algebra. That is critical, is essential. And remember what I said, you as a learner or teacher or student or math lover, if you want to learn something, you need to see the history of that idea. You need to see, let me go back to the Cartesian coordinate system, how this is transformed into the unit circle. Beautiful. Eh? To understand trigonometry, to understand trigonometrical functions. Yes. Because the radius of this is 1 everywhere. And instead of using the memory to memorize all about the unit circle, let's play with the unit circle. And understand that we have here angles, that we have here, 0 and 90 and 180 and 270 and 360 and what do they have in common? And this is when number sims come to play, which is the first podcast. Multiples of 9. And it's easy to generate ideas when you know that the unit circle and the revolutions are multiples of 9. 9 times 10. And then you integrate geometry and you combine geometry and algebra, and that combination is powerful. So you combine angles, degrees, radians, and I pay more attention to radians because this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. And we generate a revolution, and we generate the first 4 quadrants of the function sine of x. And now we understand the range of the function sine of x, why the function is moving along the y-axis between 1 and negative 1, because the unit circle. Because this point here, 90 degrees, for example. 90 degrees is no more than 0, 1. 180, or pi, is negative 1 and 0. And 270, or 3 pi over 2, is 0, negative 1. And 0 or 360 or any multiple of 360 will be here 1, 0. Do you know that x and y is no more than the cosine of the angle and the sine of the angle? Wow, this is important to integrate into trigonometrical functions. And now you can understand that the sine and the cosine in the first quadrant, that function is positive. Look at the first quadrant here. The function is above the x-axis, and now you are understanding behavior of function. When the function is positive, when the function is negative, and in calculus later on, you will see how that is important using dy dx. Because this portion over here, let me use it highlighted, this portion over here is positive, the first quadrant. 0 pi over 2. Because the sign is positive. The y-coordinate is positive. And in the second quadrant, look, the sign is still positive. Yes, in the second quadrant, the sign is still positive. But look, the sign is negative in the third quadrant. Let me use a different color. It's negative. And in the fourth quadrant is also negative. In the fourth quadrant is negative. It's below the x-axis. But it's better to understand it from the perspective of the unit circle, yes or no? It's better. It's too much better for learners and for teachers to teach effectively than using the memory. Can you imagine using the memory to understand all of that? No, impossible. No memory. And the same happened with the cosine function. No? Let me put it over here. I'm sorry for all my writings. Okay. And we have the cosine function here. Let me use a different color. And we see that the function is positive right here. Cosine is positive from 0 to 90. But it's negative. It's negative all the way to 270. Negative. And now in the fourth quadrant, again, begins to be positive. This is critical to rate of change. This is critical to the derivative function. So I don't want to extend the podcast today more beyond this because I want to hear from you. The algebra prerequisite is extensive. And in the future podcasts, I'm going to be going over, I think, 2 or more videos, 2 or more podcasts to talk about algebra prerequisite and how we connect the algebra prerequisite with the geometry and with the calculus. Later on in calculus. I'm going to create videos also, if you like it, of course, about what do you need to know. The critical questions in algebra. Critical questions. We can spend time with exponential, which is super important and powerful. We can spend time with quadratics, super important and powerful. So this is the idea of the podcast today. How to master algebra, but from these approaches, not from memory, structures, functions, and how we connect the structures, the algebraic perspective to the graphical perspective. What do you think? I love your comments. I want to finish with 2 points briefly. I read this article from The Economist yesterday. The article is, can you read as well as a 10 years old? Adults in rich countries are less literate than they were a decade ago. This is the name of the article. I invite you to read it if you have access to the Economist magazine. Basically, this study is conducted by the OECD, that is basically an organization of rich country, and they test people from 16 years old to 65 years old, I think so, in literacy and numeracy. And they found in the recent test, because they do it periodically, they do it, this type of test that is not a math test or a reading test with high level. It's just about critical thinking, about solving skills. And look at the summary of some of the countries' results. Adults between 16 and 65, look at this, in literacy and numeracy, almost 50% of the people tested, they don't even have the skills of a 10 years old. Look at the countries, Chile, Portugal, United States, and the average of the organization, England. In the article, you can see the list of countries, and this is incredible, that in literacy and numeracy, almost in some countries, the numbers are really significant because adults that they do not have the skills in reading and in arithmetic or mathematics, they do not match an elementary school student. This is really interesting that I want to mention today as a final topic of today's podcast. And the last is about very highlighted comments from our YouTube channel that I want to share with you. Let's see it. I picked this portion of the comments from one of our viewers or subscribers that relates algebra with calculus, which is the topic of today's podcast. Look at what this viewer or subscribers that I want to thank for taking the time to write the comments in our channel for the good of our community of learners. The number one takeaway from algebra: you can find the minimal solution to a problem, such as minimizing the amount of fence to box off a certain area of land. Students should be able to creatively set up their own minimizing problems. Calculus takeaway: rate of change. Students should understand how to relate to variables and the rate of change. The classical example is a ladder being pulled down a wall by gravity slides across the ground by a rate that is proportional in some way to the other end. Can we then adapt this to figure out the velocity rate of a ball on an incline and see how changing the incline changes the velocity? Very interesting ideas, powerful connections between algebra and calculus, how to make the transition from algebra to calculus when we are learning or when we are teaching mathematics. Thank you so much for taking your time to write your comments. Thank you so much for being part of the community of learners. This is the main thing in math topics. This is the end of the first podcast, and I wish you the best, and I see you next week. Thank you.